Alright, and welcome to Algebraic Transformations, Level 1. Now, it says this, the function f of x equals, let's go ahead and write this out, f of x equals x plus 3 squared minus 3 is then transformed to g of x equals f of x plus 7. Now, whenever they say it's transformed to, and you have some sort of combination of g of x and f of x, I want you to understand that that is kind of the rule. That's the rule that they're using to transform f of x into g of x. Alright, so that's the rule. Now, the first thing you should be able to do is always look at the rule and understand the type of transformation. Inside the parentheses, we see x plus 7. And this is something that we'll always call our grouping. Whatever is inside the parentheses of the rule is our grouping. And you always want to set it equal to 0. Well, x plus 7 equals 0. In order to get the x by itself, I subtract 7 from both sides, and x equals negative 7. So, what would we say here? When x equals negative 7, we could say that our transformation is that we translate 7 units left. Translate 7 units left. In fact, let me write this right here. We translate 7 units left. And of course, that's because it's inside the parentheses, and our x is negative 7. Now, this is the trickier part. It says write out the new function of g of x. So let's kind of write our rule here. We're going to write our rule in the middle in red. It says g of x is equal to f of x plus 7, close parentheses. Notice the only change here is inside the parentheses. So I'm going to go ahead and write g of x as such. I'm actually going to write, you know what, I'll even use the same color here. I'll write this, I'll write x plus 3, I'm going to leave a space, squared, minus 3. And notice that this plus 7 is inside the parentheses. So here, inside my grouping, inside the parentheses, I'm going to have to add a plus 7. So, when I fully transform f of x into g of x, it'll look something like this. X and 3 plus 7 is 10, x plus 10 squared minus 3. Alright, and that is the actual function of g of x. Alright, let's move on to our second example. Okay, here the function f of x equals x plus 4 cubed plus 5 is changed to h of x equals f of x plus 8. Now, notice here that we can take a look at our rule. It has an h of x and an f of x. So let's really establish that that is the rule. And notice that this plus 8 is outside of the parentheses. So when it's outside of the parentheses, that is our k term. We'd say k is equal to 8. And when k is a positive 8, we're going to translate up 8 because it's positive. And remember, it's outside the parentheses, being added or subtracted, so it moves us up or down. Now, B says write out the new function of h of x. So let's write out our original function, f of x equals x plus 4 cubed plus 5. And here in red, I'll go ahead and write our rule, which is h of x is equal to f of x plus 8. And here, we'll go ahead and write out g of x equals. Now, notice g of x is essentially going to be f of x, x plus 4 cubed plus 5. But here in our rule, the plus 8 is added outside of the parentheses. So I have to add the 8 outside of the parentheses as well. And so in my new function, g of x will actually be this. X plus 4 cubed inside the parentheses doesn't change because nothing was changed inside that parentheses. And here outside the parentheses, we have that plus 8. Well, 5 plus 8 is 13. So this is our new function. Oh, and I'm so sorry, this shouldn't be g of x. This should actually be h of x. My apologies. Alright, since the rule says h of x, we have to write h of x. Alright, let's move on to our third example. Okay, in example 3, it says the function f of x equals the square root of x minus 5 plus 6 is changed to k of x. And here, notice we actually have in our rule k of x, let me go ahead and label that as our rule. We see that we have the x minus 3 inside the parentheses and the minus 11 added outside the parentheses. So we know that according to our rule, we take inside the parentheses our grouping, x minus 3. We set it equal to 0. I add 3 to both sides. And of course here we see that x is equal to 3. And one thing I didn't mention in example 1, we call the value of x inside the grouping, we actually call that h. And h shifts us left or right. So since it's a positive 3, we'll say, hey, this is moving to the right 3. And here on the outside we have the minus 11. K is equal to minus 11. And so it's moved down 11. So that's how you would describe the transformation. We'd actually say this. We'd say it translates right 3 and down 11. Okay, now let's go ahead and write out our original function f of x. Here it's a square root function. We have the square root of x minus 5 plus 6. And our rule, I'll write that in red, is k of x is equal to f of x minus 3 minus 11. And let's go ahead and write out our new function, k of x. It will be this. We'll say, hey, since our original function is x minus 5, I notice here that there's a minus 3 added inside the parentheses. So inside the grouping, I'll have to put minus 3. And on the outside, we have our plus 6. But notice they've added this negative 11 on the outside of our grouping as well. So now we have everything we need to write our new function, k of x. We see here that minus 5 and minus 3, and negative 5 minus 3 is negative 8. And on the outside, we have 6 minus 11, which would be negative 5. All right, and there is your new function, k of x. I have one final example that I would highly encourage you to look at, just because these things, because we're covering every type of function in this problem. All right, let's take a look at problem number 5. Although this is truly example number 4. It says the function f of x is equal to 1 over x plus 5 plus 3, and it's changed. Remember, here is our rule because it has a p of x and an f of x, so that is our rule. And inside the grouping, we see x minus 2, so we set x minus 2 equal to 0. I add 2 to both sides, and we get x is equal to positive 2. Remember, our true x value will always be labeled as h, so h equals 2, which moves to the right 2 because it's positive. And on the outside, our k value is 15, which means that it's going to go up 15. Pretty easy. So let's go ahead and write this out as we should. Our description is that it translates right 2 and up 15. Okay, now at this point, let's go ahead and tackle our actual function. So this is where it gets a little bit strange. This is what we call a rational function. Here it is 1 over x plus 5 plus 3. We see that our rule is this p of x is equal to f of x minus 2 plus 15. And so because this rational function looks a little bit different, the question should be, well, how in the world do we change it? Well, in a rational function, your grouping is actually in the denominator of this fraction. So here, as I write x plus 5, I'm going to take a look at my rule inside the parentheses, inside the grouping. They are subtracting 2. And then on the outside, I have my plus 3. But in this function, on the outside, they have this plus 15. And so from here, I can go ahead and write my true function, p of x. P of x is equal to 1 over x. Positive 5 minus 2 is positive 3. And 3 plus 15 is, of course, 18. All right, there's my new function, p of x. And that will conclude this video. I'll see y'all in our level 2 video.